Okay, sorry about that. Took a little break. Um, so crossing down, we're going to cross down and reduce if possible, but this is um, a little bit different because if it tells you disulfur tetra oxide, don't reduce. Don't reduce. Just go ahead and say sulfur di, that means 2 sulfurs, tetraoxide, 4 oxygens. So if you see down at the bottom, SiBr4, Si, that's just 1, so we would say mono? So think about it, it's at the first, we don't say mono, we're just going to say silicone, and then tetraborate. Tetraboride, excuse me, that's bad. Tetraboride, same thing with the ides. Tetraborate would be a Br with an O or something, but this is just a bromide, so bromate. Forgive my skip. All right, let's try that again since I can't spell tetra. Hope you guys can see that. Okay, HCl, naming it covalently would be hydrogen monochloride. If it was in an aqueous solution, that would be hydrochloric acid. But if they say it's covalent or they just give you that, hydrogen monochloride is a good answer. N2S3, so dinitrogen, remember we don't ide the first, dinitrogen trisulfide. H2S, once again, another acidy looking thing. We would say hydrosulfuric acid, but because it's by itself, let's call it dihydrogen monosulfide. All right, and let's finish up on the back of the next page. Diphosphorus monofluoride. These should be really easy, guys. Just phosphorus fluoride. So let's write phosphorus fluoride. Di 2, mono 1, P2F. Silicone dioxide. So silicone oxide. And there's one silicone dioxide. Trisilicone tetrasulfide. Silicone, sulfide, tri, there's 3. Tetra, there's 4. And pentanitrogen nanobromide, we'll just write down nitrogen and bromine. And then penta, 5. And nanobromide, 9. Okay, so for the dot structures, they can be pretty tricky, and I'm going to go ahead and have, we'll probably work on some of these in class. I think we actually did, but so oxygen, in order to bond, oxygen would like 2, needs 2. So what it's going to do, it's going to double bond with its other oxygen. And so I'm getting 1, 2, 3, 4 for here, 5, 6, 7, 8, and these two, 4 shared, 1, 2, 3, 4, 5, 6, 7, 8. CO2, same thing. Carbon would love 4 more, so it's going to share with these 2 oxygens, like that. Silicone. Silicone is like carbon. It's right here, right underneath carbon, so it's got boom, boom, boom. And the fluorines, going to grab on. They only want 1 each. And we'll fill those in. And I know it's getting messier and messier, but you guys can see that each of them is filling up there. And we'll leave it at that. So what is an acid? we will start there in our next video. Make sure you go through and review the acid rules before you watch this. It might be helpful, and then I will talk to you later.